All right, good day, everyone. You are welcome once again. All right, quickly, I will be running you through how to place columns. To place columns from your architectural drawing and turning it to your structural layout. So, first of all, before you can do that, you have to know how and the things you're supposed to do before doing that. First of all, according to the heading of this topic today, how to place columns. So in this video, I'll guide you through the process of extracting a structural layout with a focus on column placement from an architectural drawing. We'll cover the following in step one. Now, in trying to place a column to form your structural layout, what is the first step? The first step is understanding the architectural drawing. Recognize key elements used in architectural plan. That means the first thing you have to do if you want to place a column is you study your architectural drawing very well to make sure that you understand every single details in that drawing. And also the key elements used in the architectural plan, you have to know them. That is step one. That is the first thing that you're supposed to know. Then the second thing is identifying the structural grid. Locate, identifying the structural grid. Locate the grid lines which are crucial for column placement. That means, first of all, you have to locate the grid lines which are crucial for the column placement. Now the third step is placing columns on a grid line. Learn how to position columns at intersections of the grid lines. Okay, for structural stability. That means if you have been able to identify which grid, according to this step 2 now, which grid you are going to use to form your structural layout, the next thing is on each grid that you have, you place columns on them. That's the step 3. Then step 4, checking alignment and spacing. Ensure that the columns are evenly spaced and aligned with the architectural design. Okay, what this one is saying now is that there's a particular spacing that you must not go beyond, depending on the material that you are using for the construction. There's a particular spacing that you must not go beyond. So that's for that. And step 5, making columns, transfer the column position from the architectural drawing to your structural layout. That basically just the steps involved in that. All right, welcome back. Okay, so after how to place columns, which we've looked at step 1 to 5, and the next thing is we'll go to more tips on column placement. More tips on column placement. See the first one here, required column spacing. That means if you want to place a column between one column to another, that we are supposed to have a maximum spacing for that before you can use maybe different types of beam section. So like this one that we have now, saying in reinforced concrete design, there's no room for larger spacing due to its visibility requirements. That means if you are looking at reinforced concrete design, for instance, we are not allowed to go to span very high, if you get. So because our concrete is kind of good in um, concrete is good in compression but is weak in tension, if you get. So but I wish we are designing for steel now, for steel design now. I think that you can span more because your steel is good in tension but also weak in what. So that is just basically for that. All right, so let's look at this. Say in reinforced concrete design, there's no room for larger span due to its serviceability requirements. For that reason, between 0 to 5.5 meter spacing between columns, between columns, between columns, between 0 to 5.5 spacing between columns, between columns, that means 230 mm by 460 mm. Now, some people will tell you this is 225 by 450. They're not still wrong. So it depends on you. Oh yeah, how 230 mm by 460 mm beam is recommended to be used. In reinforced concrete design, there is no room for larger span due to its serviceability requirements. For that reason, between 0 to 5.5 meters spacing Yeah, in reinforced concrete design, there's no room for larger span due to its serviceability requirements. For that reason, 0 to 5.5 meter spacing between columns, 230 mm by 460 mm beam is recommended to be used. Anything beyond 5 meters should have the depth increase. Yes, that means between 0 meters to 5.5 meters, you can still maintain a beam section of 230 mm as the breadth and 460 mm as the height, and you still be fine. Let's go. So the next one is column placement. I mean, this is one of the criteria for column placement. Second one is column placement, right? Arrange columns to avoid occupying architectural design open areas and prevent structural elements from disrupting intended spatial interaction. In a nutshell, what this thing means is this: you shouldn't place a column at the point where the architect wants to make use of a particular space. You now go and put your column at that point is totally wrong. At least you respect the decision of the architect by leaving that space for them, right? So, but in doing that, you should not allow that to compromise the stability of that structure. So, because of that, so that will take us to what we call when we look for walls that we can actually hide our columns. And we can actually hide our columns. That means we try our best to make our columns to be inside the wall. Say arrange columns to avoid occupying architecturally designed open areas and prevent structural elements from disrupting intended spatial interactions. Ensure columns and beams align with specified plane walls or section. What this thing means is this. That means if I actually want to do a very nice job, then I will try my possible best to make the beam and the breadth of the beam and also the breadth of the column to be the same so that they can align, they can stay perfectly well. Just like if the breadth of the beam now is like 230 mm, and the breadth of the slab, also the breadth of the column should also be 230, so that they can align very well. Or you will see this by the time we start working on it. All right, so let's go. Maintain harmony with the original design. Do not try your possible best to maintain the drawing that the architect has given you. And the next one is model stability. Choose a model or layer that is statically stable and accurately represent the structural behavior. That means you should try your best. Don't go and generate 10 meters, 15 meters. At the end of the day, at the middle of the beam, at the midspan there, you will have huge deflection, which will result to maybe some problem on the building. So please try your best to avoid that. Make sure your building is statically stable. That means achieve stability. First of all, one of the objectives of a structural engineer is number one, we achieve stability. Number one, and number two, we should be economical in our design. Economical in our design. The third one is construction feasibility. Construction feasibility, like how feasible is your design site. So select a model that is practical to construct. Consider the local contractor's technical capabilities. Or, for instance, in areas lacking reinforcement bending machine and cranes, avoid models that require heavy diameters of bar, e.g., Y40 mm bars or precast elements. In areas where you know that okay, these sites they don't really have much instruments. You understand? So in your provision, you try your possible best to at least come down to their level and not still compromise your standard also. So maybe in a place where there's no vending machines now and crane, so maybe to lift those bars and everything. So I would just decide to just maybe provide a bar that will be lower than this 40 mm so that it will be easier to work with on site. Imagine you recommending precast elements and they don't have what they can use to lift the precast element after casting. How do you do that? As for that, so the next one, like I've said before, I've mentioned that your building should be economical, economic and structural implications. Evaluate the cost-effective and structural impacts of choices. Like the cost effective, like how effective is the cost and structural impact of the choices. That means in the process of trying to achieve this cost effective now, you should also try your best not to jeopardize with the stability of the structure. For example, we said, should I just for that? Just for that. Okay. Okay, I think that is just the four of them there. These are the things that you should know.